Okay, a standard unit is a unit of measurement that is understood and accepted by people all over the world. Now, when it comes to measurements, okay, that's when you are measuring things. Okay, we have several units of measurement. If, let's say, for example, we are dealing with the measurement of time, which is very common to us. Okay, we know that time can be measured in minutes. Okay, you can also measure it in maybe hours. You can measure it in seconds. Okay, you can also measure it in days. You can measure it in maybe years, and so on and so forth. But even though all these units are units for measuring time, okay, time is a quantity. And these are units for measuring time. Okay. Only one is accepted as the standard when you come to the scientific community. Okay, and that is what we mean by that, okay, by standard units. It doesn't mean that all the other units that you are seeing in here are not valid. They are all valid. Okay, they are all units which we use, but only one of them has been chosen to be the standard. So that when scientists are working everywhere within this world, okay, they can have what? Uniform units to work with. So if, let's say, we are physicists in Ghana measuring their time in seconds, okay, then you go somewhere else, Nigeria, they should also be using the second as their standard. Okay, you go somewhere else too, they should be using what? The second as their standard. So we have many units, but only one is to be what? The standard. Just as also when you take maybe distance also. Okay, you can measure distance in feet. Okay, you can measure it in miles. You can measure it in kilometers. Okay, in meters. You can go on and on, but only one of it is accepted as the standard. And that is what we mean by what? Standard units. Okay, where we are saying that a standard unit is a unit of measurement that is understood and accepted by people all over the world. Okay, that is scientists to be specific. Now, in what we call the SI system, okay, SI system, it basically means is an abbreviation for Système International de Unit. It's French. Okay, and basically what it means is standard units. So anytime you see SI units or SI system, you are dealing with standard units. And in the SI system, or what we call the Système International de Unit system, there are 7 fundamental or base units. Okay, we have 7 fundamental or base units. And since we have 7 fundamental or base units, it means that we also have 7 fundamental or base quantities. Okay, so we also have 7 fundamental quantities. And when we say a quantity is basically anything that you can measure. Okay, we term it as what? A quantity. So time can be measured. So time is a quantity. Okay, so length can be measured. So length is a quantity. Mass can be measured. So mass is an example of a quantity. Okay, you can measure weight. So weight is a quantity. Anything that can be measured is called a quantity. But the things that we can measure, okay, you can fundamentally we have 7 of them. Any other thing else you can measure is a combination of these 7. Okay, so these 7 fundamental quantities also have units, which we call the fundamental units. So since we have 7 fundamental quantities, we also have 7 fundamental units. And then we can also say we have 7 fundamental SI units or 7 fundamental standard units. So what are the 7 fundamental units that we have? One, 2, 3, 4, 5, 6, and 7. So these are the 7 fundamental units that we have. We have the meter. Okay, the symbol is M. We have the kilogram. The symbol is kg. Okay, we have the second, the ampere, the kelvin, the mole, and then we have the candela. So these are what? Fundamental units. Okay, but then they're also standard units, as you can see. That's why we have the SI, base unit name, over there. So these are the 7 fundamental units, and these are their symbols. Okay, so we have their symbols right there. And then we have the quantities. Okay, when we talk about the quantities, we are talking about the things that they measure. Okay, so when we say the meter is a unit, what does it measure? Okay, the meter measures length. Okay, so these are the fundamental quantities. Okay, so the meter measures length. Okay, the kilogram, okay, it measures what? Mass. So even though we have several units you can measure mass in, you can measure mass in grams, you can measure mass in ton, but none of them is the standard. Okay, so you can see that we've not written grams at number 2. We've put only the standard there, which is what? The kilogram. Okay, so the kilogram is what? The standard for measuring mass. Then we also have the second, which measures time, the ampere, which measures electric current. Okay, electric current is the rate of flow of electric charge. Okay, when we say rate, we are talking about how many charges are passing a point in a circuit in 1 second. Okay, so the rate of flow of charge. We'll deal with this more under electricity. Okay, electric current. Okay, the rate at which charges are flowing. It can be measured, and it's measured in ampere. Then we have the thermodynamic temperature, okay, which is measured in Kelvin. Okay, that's the standard for measuring temperature in science. Then amount of substance is measured in the mole. The symbol is MOL. Okay, and then finally we have the luminous intensity, which is measured in candela. Okay, luminous intensity is measured in candela. And luminous basically means light. Okay, so when we say luminous intensity, okay, basically what it means is what? Light intensity. Okay, I hope that is clear. So let's do a quick test and see if this quick test would work. All right, so let's see if you were really following. So we'll put the SI base units here. We'll put a symbol here. And then the quantities, we'll put it here. Okay, so if I put meter here, you should be able to tell me the symbol and the quantity. Okay, if I put kg here, you should be able to tell me what? The SI unit base name and the quantity. So let's try and see. Okay, so let's try this and see. So the meter, what's the symbol of the meter? Yes, Edmond.
The symbol for the meter is small m.
Small m, and what's the quantity it measures?
Length.
It measures length. Very good. All right, the next one. The kg. What's the SI base unit name?
Mass.
We didn't talk about the quantity. We said the SI base unit name of the kg.
Kilogram.
The kilogram. Good. And what's the quantity it measures?
Mass.
Good.
Mass.
All right, what about the S?
Second.
All right, I can see Niyama, your hand is up. Yes, the quantity name. Jason. Jason. Yes, any of you? What does it measure?
Time.
Time. Very good. What about the mole? Sorry, MOL. What's the SI unit name?
Mole. Mole.
And what does it measure?
Amount of substance. Amount of substance.
And then we have the CD. What does the CD stand for?
Candela.
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 What does it measure?
Luminous intensity. Luminous intensity.
Okay. And then what are the K?
Kelvin.
Kelvin. Okay. And what does it measure?
Kelvin. Thermodynamic temperature. Thermodynamic temperature.
So I've left one out. Can you identify it?
Ampere.
Ampere. Okay.
Ampere.
What's the symbol?
Capital A.
Capital A. And what does it measure?
Electric current.
Electric current. All right. So you are following. All right. So kindly mute your microphones and let's continue. Okay. So you are following. So now all these units are termed as base units because they are fundamental units from which all derived units can be obtained. Okay, so a combination of two or more of these fundamental units gives us units we call the base units. Okay, you can combine these ones to get the base units. Sorry, you can combine these ones to get the derived units. So a combination of the fundamental or base units will give us what we call the derived units. So a combination of it will also give us what we call the derived quantities. Okay, that is what they also measure. Now, when we say a derived quantity, okay, a derived quantity or a derived units, let's start with derived units. Okay, a derived units are units of measurements obtained by combining two or more of the base units of a system. Okay, when you combine two or more of the base units of a system, you get what? The derived units. Combining two or more of the base units of the system. And what are the base units? These ones. Okay, we sometimes call them base units or fundamental units. When you combine two or more of them, you get the derived units. And here are some examples of derived units. So all these ones, I hope you can see the screen. Good. You have the square meter.
Yeah.
Okay, it's a derived unit. The cubic meter, the derived unit. Okay, we have the meter per second, the derived unit. Then we also have the kilogram per meter cube. So all these ones are examples of derived units. They are not in any specific order. Now, when we look at the square meter, okay, the symbol is m raised to the power 2. Okay, and the quantity it measures is area. Okay, and area is given as what? Length multiplied by length. Okay, so let's say, for example, if you have a square, okay, and you know that this side is what? 2 meters. And this side is also maybe 2 meters. And you're asked to find the area. Okay, then it means that in very simple way, the area will be what? The 2 meters by the times 2 meters. And 2 times 2 will give you 4. And m times m will give you m squared. So you see that area is measured in what? M squared. So that explains. So you see that combination of two fundamental units, okay, combining two fundamental units, the meter and the meter, give us the derived unit. So this is what? A derived unit. Likewise, when you take the meter cube, okay, the meter cube measures volume, okay, the volume of a substance. So volume in the sense that if, let's say, we take a cube like that. Okay, so this one is a three-dimensional object. And let's suppose it also has the length, breadth, and the height is also 2 meters. So the width is also 2 meters. The height is also 2 meters. Then you realize that if you want to find the volume of this box, it will be what? 2 times 2 times 2, right? So the volume will be given us the 2 meter times the 2 meter times the 2 meter. You realize that this is length times length times length, right? So the 2 times the 2 times the 2 will give us what? 2 times 2 is 4 times 2 gives us 8. And then you have m times m times m, that gives us m cubed. So you see that this is a fundamental unit. Fundamental. But as you've combined these three, they have given us what? They have given us the derived unit. So a combination of what? When you combine 3 of the derived units, it gives us the, so when you combine 2 or more of the fundamental units, we get the derived units. Okay, so that is what we have over there. Okay, then we also have the meter per second. Okay, and the meter per second is, it measures speed of, which is the rate at which a body covers a distance, or someone will say distance divided by time. Okay, distance is measured in meters, time is measured in seconds. So you combine it, you have the meter per second. Okay, and the meter per second, another way we can write it is this way: meter raised to the power minus 1. Okay, because this is mathematics. Okay, why am I saying that? When you see meter per second, okay, this means division. Okay, that's a division sign. So you can write it this way: meter per second. Okay, and you can rewrite this as m times 1 over s. Okay, any number divided by 1 is the number itself. So I can clean the 1 off. So this gives us m times 1 over s means inverse, s raised to the power minus 1. So that becomes ms minus 1. So you see why you can write this as that. Okay, so sometimes you might see something like 5 meter per second. Other times you might see 5 meter per second. It's the same thing. Okay, so however you write it, it's accepted. Whether you go this way or you go that way. Because the meter per second is the same as that one. Please, I hope you are following.
Yes, please.
Very good. Okay. Then we also have the meter per second squared. Meter per second squared is basically meter per second. So basically it's velocity divided by time, okay, which is acceleration. Okay, actually the change in velocity, which is still velocity, divided by time. And velocity we know is measured in meter per second. Okay, and time is measured in seconds. So if you do the maths, you get meter per second squared. Okay, in the sense that this is the same as writing raised to the power minus 1. So if you can rewrite this like that. Watch. You can have m s raised to the power minus 1 divided by s, right? So that can give you m s raised to the power minus 1 times 1 over s. Okay. This is the same as over 1. I see. ms minus 1 times 1 over s. And 1 over s is the same as s raised to the power minus 1. So that gives you ms minus 1 times s minus 1. Good. So you can see that if you do the maths, you are going to get what? Ms raised to the power minus 2. Okay. And that can also be written as meter per second squared, like that. And that's another way you can write it. Okay, so keep that in mind. Okay, meter per second squared. Okay. Or someone will say that if you look at it again, the units. Okay, someone would prefer to write the velocity as this. So what does it mean? It means meter per second divided by the second, which is the red one. So how do we transform this? It becomes m over s divided by, still you bring the s, right? S. So if you multiply this becomes 1 over s. Then what does that give you? M over s squared. Okay, so meter per second squared. Then we also have the kilogram per meter cube, okay, which measures density. Okay, density is the mass per unit volume of a substance. Okay, when you take unit means 1 meter cube. So when we say mass per unit volume, we mean mass for every 1 meter cube of a substance you take. So when you take 1 meter cube of a substance, what is the mass of it? That is what we mean by density, mass per unit volume. Okay, and density is given as mass divided by volume. And remember that we said mass is measured in kilograms, and volume we know to be measured in meter cube. So you combine it, you get kilogram divided by the meter cube. So kilogram per meter cube. Okay. So that means that the kilogram per meter cube is a combination of the kilogram, which is a fundamental unit, and then we have length times length times length, or meter times meter times meter. And that gives us kilogram per meter cube. And another way to write it is like this: kg m raised to the power minus 3. So these are derived units. Okay, but these derived units, okay, they don't have any special name. We also have derived units that have special name. Okay, because they were simply named after famous scientists. So because some derived units were named after famous scientists, they have a special name. So some derived units have a special name because they were named after famous scientists. And what are some of the examples of these derived units that have special names? So you can see a few on your screen. A few. You have the Newton, which you may have even come across it already. The Newton. It's a derived unit with a special name. You have the pascal, the joule, the watt, the coulomb, the volt, the ohm, the farad. Okay, we can even add a few more to it. But these are common ones that you are going to be coming across. And these derived units, we are saying that they have what? A special name because they were named after famous scientists. So the Newton, the symbol we use to represent it is a capital N. Okay, capital N. And it has an equivalent. Okay, the equivalent is actually the kilogram meter per second squared. And why is that so? Because the Newton, the quantity it measures is force. Okay, Newton measures force, and force, mathematically, force is given as the product of mass and acceleration, or you can say mass times acceleration. And remember that mass is measured in what? Kilogram. Right? And acceleration is measured in meter per second squared, as we said. So you combine it, you get kilogram meter per second squared. And the kilogram meter per second squared is what we write as what? N, meaning Newton. So instead of writing maybe 5 kilogram meter per second squared, okay, we can just write 5 Newton. We know that Newton means this in physics. Okay, so you may be seeing the Newton a lot. You will be seeing it, not even a may. You will be seeing the Newton a lot as you are moving further and further. Okay. Anytime you see the Newton, understand that the Newton is just basically kilogram meter per second squared, which has been given a name what? Newton. All right. Now, since you can write the meter per second squared in this way also, you can also write it as kg ms raised to the power minus 2. That is also accepted. But instead of maybe memorizing this, okay, you don't even have to memorize it. You can just remember the N and put it there, Newton. Then we also have the pascal. Okay, the pascal measures pressure. Okay, that's the force acting over a unit area. Unit meaning 1. Unit means 1. So when we say unit area, in terms of SI units, the force acting over an area of 1 meter squared, how much force is acting at that area? We call it pressure. Okay, the force acting on that particular area, we call it what? Pressure. So mathematically, pressure is given as force divided by area. Okay, force is measured in Newton. Area is measured in meter squared. So together you get the Newton per meter squared. And the Newton per meter squared is what we refer to as Pascal. PA, we just use PA to represent it. So when you see PA, okay, the PA simply means the Newton meter, Newton per meter squared. Newton per meter squared. Okay, Newton per meter squared. That is the Pascal. Okay, and measures pressure. Again, already the Newton, we know that the Newton is equivalent to what? Kilogram meter per second squared. Right? So if you look at it carefully, so if you are saying that pressure is force divided by area, and force is measured in Newton, area is measured in meter squared, already we know that the Newton is equivalent to what? Kilogram meter per second squared. That's the value of the Newton, or we can write it this way. Kilogram meter per second squared, all divided by this m, which becomes m squared. So if you look at it carefully, you can see that the m will cancel the m, the squared, right? This m will cancel the squared. And what will you be left with? You'll be left with kg s minus 2 over m. Are you seeing? Or you can say that kg s minus 2, right? I'm making it very simple for you, times 1 over m. You see, this is inverse. 1 over m is m minus 1. So you can write this kg s minus 2 times m minus 1. So if you add it to it, you put all this together. Okay, basically you have kg s minus 2 m minus 1. but most of the time we bring the m before the s. So kg m minus 1 s minus 2. So all this is actually the pascal. But you don't have to remember this. Please, are you following? Can you see my screen?
Yes.
Okay.
Yes, sir.
So all this over here is what we call the pascal. Okay. So kgm raised to the power minus 2. So you can see it in the second one over there. kgm minus 1 s minus 2. That's the equivalent. So we are saying what? SI base unit equivalence. Then the joule measures energy or work done, which is a product of force. So work done or energy is a product of force multiplied by displacement, or what you sometimes call distance. So this is Newton, this is in meters. So Newton meter. Okay, so the Newton meter. And when you put the Newton in there and you simplify it, you're going to get this kilogram meter squared per second squared. Okay. And then we have power, which is the rate at which work is done, or energy per unit time. So energy divided by time, joule per second is power. That's the equivalent of the watt, which when you fix in the value of the joule, if you take the joule, you put it here, you simplify it, you're going to get kilogram meter squared s raised to the power minus 3. Okay, so keep that in mind. You can take a screenshot of this so that it's those of you who can take screenshots. I think, Chris, you can take a screenshot on your device. So take a screenshot on Skype so that it will be on the platform for them. There are some few which has not been added, but maybe I can also add it for you. Okay, we have okay, the coulomb C measures electric charge, okay, which is the product of time and current. Then we have the volt, which measures what we call electric potential, or sometimes you call it voltage, okay, which is equivalent to the watt per ampere. And the SI base unit equivalence is this. But instead of writing all this, we just put V there. Okay. Then we also have the ohm. The ohm is a Greek letter, ohm, the omega letter. Okay, ohm. So notice the symbol, ohm. And the ohm measures electric resistance, okay, which is the opposition to the flow of current. When current is going through a conductor, okay, the material has the ability to oppose the flow or to resist it. Okay, for example, insulators, they resist the flow of electricity more than conductors. So you can measure the resistance within the material, how it is opposing the flow of electricity. It doesn't allow electricity to flow through it easily. You can measure that. Okay, and it's measured in ohm. Okay, and that is the equivalent of the ohm. Okay. Then we have the farad, which measures capacitance. So most of these ones, you come under it when we are dealing with electricity, direct current and alternating current. You come across them. We also have one called the Henry. Okay, the Henry. Okay, the symbol is H. It measures what we call inductance. Okay, and then the inductance is equivalent to the second per farad. We also have another one we call the Weber. Okay, the Weber, the symbol is WB. Okay, all these were named after famous scientists. Okay, and it measures magnetic flux. So under magnetism, you deal with this, okay, which is equivalent to the Henry per ampere. Okay. Then another one called the Tesla. So you can see where the Tesla car, they got the name from, Tesla. Okay, the symbol is capital T. Yes, one of you, your hand is up.
Sir, please, what is the SI base unit equivalent for the Henry and Weber?
Oh, okay, the Henry. Well, it was not necessary, that's why I left it, but it's equivalent to the kilogram meter squared. Let me put it there. Kilogram meter squared, second squared, ampere squared, ampere. That's a Henry, the equivalent. This one is equivalent to kg m squared. You don't have to memorize them, okay?
Okay.
Then the Tesla, okay, that's equivalent to the kilogram per second squared. Then you have per ampere.
Thank you.
So this one you can say Weber per meter squared. And this one measures magnetic field strength. You can see magnetic flux density. Okay. You don't have to memorize these things.
Okay.
I've placed it there for understanding, so that you understand that when you see the derived units with special names, they were gotten from here. Nobody expects you to remember these things. You can easily check your books for reference sake to know them. All right, so these are the derived units that we have. All right, so the ones without the special names, and then the ones with what? The special names. Okay, can we move on? Let me know if we can.
Yes.
Okay. Then that leads us to metric prefix. Okay, some of your textbooks you see SI prefix or metric prefix. Metric prefix. Now, when we say a metric prefix, okay, a metric prefix is basically a unit prefix. Prefix, so pre, meaning comes before. Okay, it's a unit prefix that precedes a basic unit of measure to indicate a 10th multiple or fraction of the unit. Okay, so it indicates what? A 10th multiple or fraction of the unit. So it comes before a basic unit. Okay, now basic in this sense does not mean base unit. So I'm using two words here. Okay, don't consider basic unit to mean base in this sense. Okay, basic in the sense that if, let's say, you take these, let me use something you're familiar with. You people are familiar with computers. So you've heard of the byte. Have you heard of the byte? Under computers, when you are storing data.
Yes.
Good. So this, let's take this to be a basic unit. Okay, basic unit. Any other thing that follows this basic unit becomes a prefix. So you've heard of the kilo, and then you add bytes. So the kilo is a prefix. You've heard of the mega, you put it before, then you add bytes. You've heard of the this thing, tera, then you add what? Bytes. So are you seeing this is what we mean by the prefix? It comes before the basic unit. Okay, so it comes before it. Okay, so these ones are the metric prefix. Okay, you bring them before the basic unit. So another example is let's say the gram being a basic unit. Okay, not base unit. Two different things. So if we take the gram, we can put a prefix in front of it, maybe kilo, in front of the gram to get kilogram. You can put a milli in front of the gram to get what? Milligram. Okay, you can even put a centi in front of it to get centigram. So it means that the meter will be a basic unit. The meter is also a base unit, but over here it's acting as a basic unit. Okay. And then the prefix can come before it. So centimeter, kilometer, meter, millimeter. Okay. All right. So let's take the definition again. So what are we saying? We are saying that a metric prefix is a unit prefix, okay, that precedes, comes before a basic unit of measure, and it indicates a tenth multiple or fraction of the unit. Okay, some of your books will say it indicates a decadic multiple, tenth multiple or fraction of the unit. So those are what we call metric prefix. And here are some examples of these metric prefix. Okay, we have the para, tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico, femto. And you can see their multiplication factors on your left side. So you have the multiplication factors over there. Okay, we have the prefix right there. And then the prefix also have symbols. So mostly we use the symbols. Okay, we don't write them in full, just so you can see P, maybe M, meaning parameter. PG, paragram. CM, centimeter. The C from here. Then you add the basic units. Okay, so as you can see over here, we have these very simple prefixes. So if we look at the ones that you are going to come across in physics mostly, okay, let me circle those ones for you. I'm talking about the SHS level, all right? Mostly is D6. Mostly these ones. Okay, and even you can take these ones off. I'm not saying forget them. I'm talking about the ones that you can come across the most. So the giga, the mega, the kilo, the centi, the milli, the micro. Okay. As for these ones, 6 in SHS syllabus, you're going to meet them. When you're talking about this thing, capacitance, mostly you're dealing with microfarad. Okay. When you're talking about distance, you're dealing with millimeter and centimeter before you convert it to the standard meter. Okay. When you're dealing with mass, you deal with a kilogram. Okay. When you're dealing with energy, you deal with joule, but you can have a megajoule or a gigajoule. So you see that let me put asterisks on them for you so that you don't forget them. You can take a screenshot. Now with these prefix, it's very simple to convert from one prefix to the other. Okay, I'll show you a very simple trick where mostly I teach students that they can use to convert from one to the other without really stressing themselves so much. Okay, I'll teach you the simple way. It's a very, very, very simple way how to convert from one prefix to the other without you thinking too much. But nonetheless, the multiplication factor has to be in your head. Okay, so let's say giga, you know, is 10 raised to the power 9. So if let's say you have something like 1 giga meter, what is it equivalent to? Yes. What do you think is equivalent to? And when we say 1 gigameter, I want someone to try. Yes. Any hand? Chris. Nana. Unmute your microphone. Someone, I can hear someone say, oh, sir, it's calling me. Trouble. Yes, Chris, what do you think it means? The giga, the multiplication factor is 10 raised to the power 9. So you can rewrite this as 1 times 10 raised to the power 9 meters. So that's what 1 giga meter means. So if you count the zeros, okay, that means there'll be 9 zeros, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9 meters. That is what it meant by 1 gigameter. Are you seeing? Just like when you say 1 megameter, what does it mean? What it means is 1 times 10 raised to the power what? Then what's the value of the mega? 10 raised to the power 6. So that would be 1 million meters. So that's equal to 1 million meters. Likewise, when we say 1 kilometer, okay, that means 1 times 10 raised to the power 3. That's 1,000. Meters. Okay, so that's what? 1,000. So 3 zeros meters. So that's why we say 1 kilometer is equal to 1,000 meters. Please, are you following?
Yes.
Good. Let's jump to
Yes,
the centimeter.
please.
Say 1 centimeter.
Yes, sir.
Okay. Interested. When we say 1 centimeter, okay, 1 centimeter simply means 1 times, then you look at the centi, 10 raised to the power minus 2. So you put it there, 10 raised to the power minus 2 meters. That's what 1 centimeter means. Okay. And what is 10 raised to the power minus 2? Mm-hmm. Yes. 10 raised to the power minus 2.
0.01 meters.
Very good. So it means that that's equal to 0.01 meters. Are you seeing? So that's how to convert from the prefix to the base unit or basic unit. From a prefix to a basic unit, you just multiply the multiplication factor for the unit. So converting from the prefix to the basic unit, you just multiply. Are you seeing? So that's a very simple one. But what if you are moving from one prefix to the other? What you do is that after you change it to the basic unit, so all these are the basic units in basic terms, okay? Okay. After you change it to these ones, let's say you want to move the 0.01 to giga, then you have to divide it by the prefix you are converting to, or maybe you are moving the this value 1 billion, okay, 9 zeros, to mega. You want to change it to a mega value. Then you now divide it by the prefix you are converting to. Let me repeat it again for those who missed what I said. Okay, so let's say oh, sorry. Okay, so let's say you are converting 1 gigameter to megameter. Okay, what do? It will be, let me use colors because you people understand colors a lot. To megameter. So what will you do? You first to be 1 times, then the prefix of what you are converting it to move it to the basic unit. So 1 times 10 raised to the power 9. That will change it to the basic form, which is 1 billion, 1 and then 9 zeros, right? Then now to convert it to the mega, you divide it by the prefix you are converting to. So mega is 10 raised to the power 6. And then you do the maths on your calculator. Very, very simple way. So 1 times 10 raised to the power 9. That will send it to the basic form, right? And then you divide it by the prefix you are converting to. So 10 raised to the power 6. Okay. And then that will give you what? Equal to 1,000 megameter. So 1,000 megameter is 1 gigameter. So that's a simple trick. Multiply by the prefix attached to it, and then divided by the prefix you are converting to. So you don't have to think too much. Multiply by the prefix attached to it, then divided by the prefix you are converting to. And then you get it in that form. Okay, so keep that in mind. If there was no prefix attached to it, then it means that if, let's say, it was just 1 meter, then it means you just remove this and you just divide it by the prefix you are converting to. So it means 1 divided by that. Okay, so you see that there's no prefix there. So you don't multiply by any prefix. It's already in the basic form. Okay, and then this will be what? This thing, 10 raised to the power minus 6, right? So if you say 10 raised to the power minus 6, that means that we are bringing, I think, 5 zeros. So that'll be 0.12345. So very simple conversions. Okay, multiply by the prefix and then divided by the prefix you're converting to. Finish. Please, I hope it's clear. Or you want to take examples?
Yes.
Okay, let's take some examples. Right. Can I clean what I've written on the screen?
Yes, please.
Okay. Okay, so let's take some examples. You are going to do these examples by yourself first. I'll give you probably roughly 2 minutes, and then we look at it together. So convert 5 centimeter. Let me make it simple for you. Centimeter to millimeter. Okay, so you can see the milli. It's right there. And the centi is there. Or you can even say that number 2, convert 1 centimeter 1 centimeter to millimeter. I hope you are following. The number 3.
Yes.
Okay. Convert 500 grams. See that there's no prefix attached to it. To kilogram. Okay, let's add some more. 100 microfarad. Hundred microfarad to farad. Okay, so I think 1 minute for each is okay. So I'll give you 4 minutes and then we'll compare answers. So start work. All right, so are you done? Hello.
Sir.
Okay, the time is up.
No.
Which one are you on?
Sir, please, I'm on the last
Question
one.
3.
Hey, question 1. Who said question 1?
Question 3.
Question 3. All right.
Question 4.
Question 4. Okay.
Question 4. Question 4.
Okay, if you are done, kindly raise your hand and let me see. If you are done, kindly raise your hand. Okay, all right, so let's start with question 1. Our time is fast spent, so let's quickly answer this and see. So let's start with Edmund. Edmund, what do you do for this?
For question 1,
Yes.
I got 50 millimeters.
50 millimeters. So you did 5 times 10 raised to the power minus what? 2 divided by 10 raised to the power minus. And that gave you 50 millimeters. All right, what about question 2? Same person.
Question 2, I got 10 millimeters.
And what did you do?
I did 1 times 10 raised to the power negative 2 divided by 1 times 10 raised to the power negative
3, and that gave you 10 millimeters. So you see, we say 1 centimeter is equal to 10 millimeters. All right. Can we deal with the next one? Can I clean? Can I clean it?
Yes.
Okay. Let's deal with number 3 and number 4. So how do you go about number 3? It's already in the basic units. So you don't multiply.
Yes.
500 what? Edmond.
500 times 10 raised to the power 3.
There's no prefix here. There's no prefix attached to it. So you don't multiply it by any prefix. It's simply divided by the prefix you are converting to. So what does it become?
0.5 kilograms.
So 0.5 kilograms. Very good. So we're just dividing it by 1,000. Okay. What about the next one? The micro.
The next one, I divided it by 1 million.
You multiply first by what? Micro. And then there's no prefix here, so you divide it.
Yeah.
Okay. So it becomes 10 times then the micro. 10 raised to the power minus 6. And there's no prefix in front of the farad. All the prefixes I've colored it for you. So that's all. So what would that give you?
that'll give me
0.001.
0.001.
Okay. Zero 0.001 farad. And you bring the unit there.
Okay.
All right, so we'll end here for today. When we come back, that is tomorrow, we'll continue with dimensional analysis. Okay, we'll continue from there, and then we'll see the way forward. All right, so have a nice day. Bye-bye.
Bye. Bye.